we're going to go ahead and pick up where we left off yesterday. So just a quick reminder. This section was all about finding the inverse of a matrix and one particular technique that we can use to solve a system of equations using an inverse matrix. So we talked about the fact that if we multiply a matrix by its inverse, we should get the identity matrix, and the identity matrix is the equivalent of a 1, and that came in handy when we're doing something like this. So if I'm solving this equation right here, and this is one matrix times another matrix, and I want to get the variable all by itself, if I multiply by the inverse, that will turn A inverse times A into the matrix equivalent of a 1. And that's one way that we can verify that we have the inverse matrix correct. Okay? So we talked about this technique that you're not going to find in your book. Okay? The inverse of a matrix is 1 over the determinant times the transpose of the matrix of cofactors. We talked about the transpose being a right-hand pancake flip. You already know how to find the determinant, and you know what cofactors are. We got that checkerboard of pluses and minuses and finding the minors and all that sort of stuff. Okay? And the fact that we have to find the determinant means the only type of matrices that have inverses are square matrices. Because if it's not square, it doesn't have a determinant. Okay? So we went through and we found some 2x2 inverses. Pretty easy to do. And then we found this nice little shortcut method that makes it really nice. And we went through and we did this one where we did a 3x3. Okay? We talked about what the option is in the book for that also. Okay? And then we solved one problem where we found the actual inverse, solved the entire system of equations. Okay? So here's what we've got left to do today. I'd like to take a look at this problem right here and do one of these. I mean, do we really need to do 2 of those? Don't really need to do 2 of those. Okay? So I'm going to get rid of this. Okay? So on this problem right here, what is matrix A? What's the coefficient matrix? -1, 2, 7, 7, right? Okay. What's the matrix C? What's the answer matrix? -4 and 12, correct? Okay. If you keep this in mind, that when we solve that system of equations, if I've got AX equals C, the way I would solve that is by multiplying both sides by the inverse. These cancel out or make the matrix equivalent of a 1, so the answer is just going to be A inverse times C. That's it. That's all we're doing. If you identify the coefficient matrix, the answer matrix, we're going to find the inverse of this matrix, times it by that, and that's the answer. Okay? So if I find the inverse of this, first thing I need to do is find the determinant. Determinant is -21. Not a very nice number, right? So we're going to do 1 over -21 times the transpose of the matrix of cofactors. Or should we use the shortcut on this? Let's just use the shortcut. The shortcut is, what happens to the 2 of these? Trade places. And these 2 change signs or get the opposite sign of what they used to have. So this is a -2 and this is a -7. Any questions there? Okay. And again, this is a nice form of the inverse because all the numbers in here are whole numbers. Okay. It's going to be a little bit easier to work with. So this right here is A inverse. And then I'm going to multiply that by the matrix C, which is -4, 12. 2 by 2 here, 2 by 1 here. What do I end up with? Inner dimensions are the same. We end up with a 2 by 1, right? So like I showed before, I'm going to leave the 1 over -21 outside, and then we're going to figure out what these 2 entries have to be. So this is going to be -28 minus 24. So that's going to be -52. Is that right? Second row, first column, this is going to be 28 minus 12. So this is going to be 16. 28 minus 12. Am I making any silly arithmetic errors? Okay, imagine how awful this would be if I had distributed the negative 1/21st through and I had a bunch of ugly fractions here. Bit of a mess there. So to finish this off, here's what we get. If I distribute that through, I get negative 52 over 21. Let's see, does anything go in there evenly? Into both of those? Nope. Nope, this would be 2 and 26, 2 and 13, so nothing there. So this is negative 52 21sts. Oop, it's negative on the top and bottom, so this is going to be positive, right? The next one's going to be negative, and that's just going to be 16 21sts. And remember, it said the variable matrix was the matrix X, so this is X and Y, so you can see X has to be 52 21sts, Y has to be negative 16 21sts. Any questions? Okay, so of the two of these, which one do you want to do? You want to do B? Why B? Okay, yeah, I mean, if we pick A, let's write down the coefficient matrix. Coefficient matrix would be 1, 1, 0, negative 1, 3, 4, 0, 3, or excuse me, 0, 4, 3. The nice thing about that, finding the determinant and finding the minors is going to be a heck of a lot easier, right? Okay, and the matrix C is 3, negative 3, 2. No shortcut to this, so let's go ahead and find what A inverse is. 1 over the determinant, so we'll figure out what that is. Did you get negative 4? Yeah. Good? Transpose of the matrix of cofactors. So I would do it this way every single time. Find the determinant, do 1 over the determinant, put a t right here, and now we're going to find the cofactors. Okay? What did we suggest yesterday to make sure you don't forget? Yep. Negative here, negative here, negative here, negative here. Checkerboard of pluses and minuses. Okay? So I'm going to cross out that row, or that row and that column. So we're going to have 9 minus 16, negative 7. So I've got a little bit of an advantage here being able to write on there and then just erasing it. However you find those minors, just be careful and you'll get them right. Negative 3, 0. So I'm going to write down a minus 3, right? So this is a positive 3. Negative 4. 0. Okay, You go ahead and finish the other 6. And I'm going to call on Brandon to give us the last 3. Okay. Not yet. Go ahead and find them. You already have them? Okay. No, get them done. Okay, did I get those 3 right? Did I get the second row right? Okay, Brandon, what's this one right here? No, okay, then the pressure's on. Better get this right. We're going to make fun of you.
I'll get it right.
Do you want me to write a question mark after that?
Yeah, 4 is the first one.
Okay.
And then it's 3. So it's like positive 3, right? Or no, never mind. I did wrong. 5. I don't know.
1 and 4.
Yeah.
1.
Oh, never mind. It's 0. I was thinking minus 1.
So what do I write here?
4.
Okay, I write a 4 here. Does it stay negative 4?
Yes.
Are you sure?
Positive.
Okay, no question mark on that one.
So that's 2. No, 4.
Which is it?
4.
Question mark or no? No question mark. Is that right?
Yeah.
Okay, got that. Now, again, there's no shortcut on a 3x3. This is as short as it gets. Okay? If you tried this stuff in the book, it would be absolutely awful, especially if you did it by hand. Okay? Really, really horrible. So we still need to transpose this. So I'm going to slide this down here. So we're going to have negative 1/4. And then I'm going to do a right-hand pancake flip. I don't need the T on here anymore because I'm going to take this and I'm going to flip it. The diagonal stays exactly the same because we slid our right hand under there and flipped it over. This is 3, -4, and -4. This one up here becomes -3. That's a 4, and that's a -4. Okay? So these 2 switched places, these 2 switched places, and these 2 switched places. Okay? Now, if I wanted to just find the inverse, I'd have to distribute that through. Should I distribute it through on this one? Putin says yes. Why? There are lots of 4s, but there are also a couple of 3s and stuff like that. So if we distribute it in, it's going to make a bunch of 1s and -1s. That's going to make the multiplication a little bit easier. If we don't, it's going to make the numbers whole numbers, okay, which are easier to work with, but they are going to be a little bit bigger. Okay, almost without exception, okay, unless you're Putin, you probably want to do this. Okay, so we'll do the 3, the -3, and the 2. You might want to try both and see which one you like. But if you've got fractions in here, it generally turns into a bit of a mess. Okay? So when I multiply these together, I'm going to have -1/4 times, and let's check and see what we get. First row, first column. First row right here, first column right here. Fairly large numbers to work with on this, but let's double check here. -21, and 9, and 8. -21, and 9, and 8. -4. Okay, why does that make us feel good? Turns into a 1. It's going to be a nice number. Okay, they don't all turn into nice numbers, but that one in particular does. So I'm going to have a 9, a -9, and this is good news. 2 that cancel, that's a -8, also divisible by 4. The last one, -12, 16, and 8, right? So we get positive 12. Oh, you're right. You're right. Yep. So it's just 8. So that means I get 1, 2, negative 2. And that was equal to the variable matrix x, y, and z. So we get 1, 2, negative 2. Okay. Any questions? Okay. What would happen if I took this matrix right here and multiplied it by this matrix right here? You get one in reduced row echelon form. You get the matrix equivalent of 1. We call it an identity matrix. Okay? All right. Any questions? Okay. I'm going to go ahead and